everyone. In this session, I would like to explain the bitwise operators in Python programming. Okay, bitwise operators perform operations at bit levels only. The bitwise operators perform operations at bit level only. But what the operator expect is the operator expect their operands must be a the operands to be a integers. The operands to be a of integers and treat them as a sequence of bits. Okay, so what we are passing is we have to passing the operands as to be a integer, but the internally those operands can be treated as a sequence of bits. Okay, so these are some of the bitwise operators that can be supported by the Python. The first is called as bitwise and second is called bitwise or bitwise XOR, bitwise complement or bitwise not, shift left, shift right. These are the six bitwise operators are supported by the Python programming. Okay, so first let us discussing the truth table of these bitwise operators. Then we have discussing with some example. Okay, let's see the truth table of these bitwise operators. Let's see. A is one operand, B is another input. Okay, so if you want performing the logic bitwise and in between A and B, so the output is A and B output is one. So both inputs are one, otherwise zero. So this is bitwise OR. The output of bitwise OR is one if any input is one, either 0 1 or 1 0 or 1 1. The output is one, otherwise zero. So this is bitwise XOR. The bitwise XOR is the output is 1 if both inputs are 1 or 1 0, then only the output is 1, otherwise 0. So that is complement or negation. So the bitwise negation means it is the complement of A, that is 0 0 1 1 means 1 1 0 0. Mistake here, it is 1 also 1 1 0 0. We are getting negation of A, which is the two tables of bitwise operators. Okay, so let us and one more another two types of operators are called as shift left and shift right operators. Okay, let's take as axis one operand. Okay, the operand can be represented as a bits as like this. Let us zoom like this. Okay, so if you want performing x shift left one means, so shift left one means, okay, so shift left in shift left the leftmost bit is discorded by one bit and the zero is added to the rightmost bit, that is shift left by one. That means this zero is discorded and the zero is added to here. Then the result is 0 0 1 1 1 0 1 0 is the result of shift left by 1. Like if you want to shift left by 2, two leftmost digits are discarded, two zeros are added to the rightmost. Okay, that is for shift left. Okay, shift right means the rightmost bit is discarded, added zero to the leftmost. This shift right by one. This one is discarded and zero is added to the rightmost. That means 0 0 0 0 and triple one zero is output of shift right by 1. If one performs shift right by 2, the rightmost two digits are discarded, added two zeros to the leftmost. That is the shift right by 2. Okay, that is some of the examples of bitwise operators. So let us discussing some example. Let's take as, for example, I can take as some a equals to, I can take as 2. Okay, so b equals to, I have taken as 3. Okay, so this internal it can be treated as 8 bits, that is called as the binary equivalent of 2 is 0 0, that is 0 0 1 0. Yeah, that is the internal binary equivalent of A. Okay, and the binary equivalent of B is 0 0 0 0 and 3 is 0 0 1 1. Okay, that is the binary equivalent of B. Okay, so if one performing A and with one performing A and with B, bitwise and with B. Okay, what is the result of A and B? That means A for performing A and with A and with B. Okay. So the result is what is bitwise and both inputs are 1, the output is 0. That's why this is 0 0 is 0, again 0 0 0, again 0 0. Bitwise and means 1 1 is 1, 0 1 is 0. That is 0 0 0 0 1 0. This is equivalent to the integer number is called as 2. So if you want perform A and B, the output is 2. Okay. If you want performing A bitwise or with B, bitwise or with B, okay. So the output is bitwise or means if any input is 1, output is 1, otherwise 0. That's why 0 0 0 0 and 0 0 1 1 is 1, 0 1 is 1. Okay. So this is equivalence to, okay, B. Okay. Let's see A, okay, not performing bitwise XOR. What bit to accept to the table? 0 1 or 1 0 is 1, otherwise 0. That's why 0 0 0 0. Okay, so 0 0 1 1 is also 0, 0 1 is also 1. That it is equal to which one? 1. Okay, that is bitwise XOR. You can see complement of A or the negation of A. Okay, so if we take as this one. Okay, complement of A is we are getting, okay, so 1 1 1 1. Okay, so getting as 1 1 0 1. That is negation 1. Okay, so now that is the bitwise uh, complement operator. Again, if you want performing A, okay, shift left, for example, one digit. A shift left, one digit. So what can happen is, so shift left one means the leftmost bit is discarded, add 0 to the rightmost. This is the leftmost bit. This bit is discarded, add 0 to here. Then what you're getting is, so we are getting, okay, so 0 0 0 0. This 0 is discarded, okay, then getting as the 4 zeros, and we're getting the 0 1 0 0. This is equal to how much? Equals to 4. 100 means 4. Okay. On performing A shift right 1. That means the rightmost bit is discarded, added 0 to the leftmost. That means we're getting the output is, okay, 0 0 0 0. Okay, again 0 0. Rightmost bit is this rightmost bit is discarded. Okay, again added uh, 0, again 1. Okay, so this equals output is 1. Okay? So these are the results we are getting if you are performing the bitwise operations. Okay, let us discussing with examples. Let's take as A equals to 2. Okay, so B equals to 3. The first one is A. Okay, so logical and B. Output is 2. Okay, A bitwise OR with B. Output is 3. Okay, if you want to perform A, shift left 1. Output is 4. A shift right, output is A shift right 1. Output is 1. Okay, so these are the bitwise operators that can be supported in Python programming. Okay, now next concept we are discussing uh, operator precedency. Operator precedency or associativity of operators. Okay, these are the operator precedencies. That means when we are using these operator precedency means if the expression contains more than one operator, then the highest based upon these precedency we are evaluating the expression or the computer evaluating the expression. The highest precedence of operators are, this is the tuple, okay, this is the list, this is the dictionaries. So these three operators are highest precedency. That means tuple, list, and dictionaries are highest precedency operators. Clear? And one is called as power operator, the next highest priority operators. Next, unary plus, unary minus, unary plus, or the complement is the next highest priority operators. Okay. Then star and division, floor division, modulus of the next highest priority operators. Next, arithmetic plus and also arithmetic minus or plus and addition subtraction is the next highest priority. Next, shift left and then shift right is next highest priority operators. And then bitwise and bitwise XOR, then bitwise OR. Okay, then less than equals to, greater than equals to, clear, equals to, not equals to, not equals to, okay, and also assignment operators, we call it next highest priority operators. Okay, comparison, identity, sequence, membership test. These are all called as, okay, next highest priority operator. That means these are all called as the next highest priority operators. Clear? So now, how we are evaluating this expression? Clear? And also that means what highest priority operators? The highest priority or tuple, list, and dictionaries. Next one is called as power operators. Let's we discuss with some example. Let's take as I can take as some example is I'm taking one example. Okay, a for example plus let's take as 2 plus 3. Let's take as star 4, and also I've taken some star 2. Let's take this is one example. For example, I am performing some 4 minus some also some plus. Let's take this is one example. This is the one expression. This is the one expression. So how this expression is evaluated? So based upon the operator precedency, this expression is evaluated. Okay. So once if you can see what are the from this precedency table, plus, minus, star, and power. Which one is the highest priority? Star star is highest priority. That is the power is the highest priority from this table. That's why the first power is evaluated. Okay, that means 4 square. That is 16. Okay, that means we're getting 2 plus 3 minus 2 plus 3 star 4 star means 16. Now next one is highest priority is, let's see, plus minus star, the highest priority is, let's see, star is highest priority, then we're having the plus and minus. That's why the star is evaluated first. Okay, that means 3 star 16, that equals to 48. Okay, 2 plus 3 minus 2 plus 3 16s are 48. Okay, next plus minus plus. So here you can see plus and minus having the same priority. That means both plus and minus are equal priorities. If we have equal priorities, okay, we are also following the left to right associativity. Okay, that means which one is comes first from left, that can evaluate first. Okay, so in this expression, the associativity plus minus plus, left to right associative we are following. That means this is the first plus, that's why we have to evaluate in the 2 plus 3, that equals to 5 minus 2 plus 48. Next we are evaluating the next, first is minus again plus, both are equal priorities. We are using the left to right associativity. That's my first bias is evaluated. 5 minus 2 3 plus 48. Now we have only the single 48. 3 plus 40, that is 51. This is the result of final given expression. This is what given expression. Clear? So let's see, it's can be executed. For example, in this, if we are executing this one, okay, we are getting as P1. Okay, likewise, at that time, if you want evaluating